So my name is Russell Wolf. I'm a Google developer expert for Kotlin, and I work at TouchLab doing multi-platform things. So we help clients adopt it, do some open source work, do various other bits of consulting. And I'm going to talk to you about kind of some of the things we've learned about using KMP in production and how that can differ from when you're just getting started. So, start with just kind of a brief overview of what Kotlin Multiplatform is, in case you're not familiar. So, as an Android developer, you might be used to Kotlin on Android and the JVM, but of course it also can run in a bunch of other environments. So, there's backends for JavaScript, for native via LLVM. There's WASM now that just came out experimentally. So lots of exciting things going on. We're mostly going to focus for today on Android and iOS. And the kind of major concepts that multi-platform brings to the language is this distinction between platform code, which knows where it's running and can talk to the APIs of that platform, and common code, which is shared between platforms. And so like has access to fewer APIs, but can run in more places. And together, those two things give us this nice flexible interop where you can share the code that you want to share. You can kind of dive into platform-specific things and access the native APIs of the platform when you want to do that. And your shared code becomes essentially just another library, like any other dependency that you might have in your native app. As of last fall, Kotlin Multiplatform is in beta. It's very exciting. It's very usable in production, even though it's beta and not more than beta. We at TouchLab have been using it actually since it was pre-alpha, so maybe I'm not a great person to tell you that, but there's a lot of really exciting stabilization work that's happening right now. They're kind of solidifying which of the different targets are supported to what degree and things like that. They're delineating kind of what parts of the API you can depend on more and less. And it's just neat seeing a lot of movement from the JetBrains team on bringing this stuff finally to that stable milestone. The mental model I like to use when I think about multi-platform things is this Venn diagram. So the left side is the Android code that you may be used to writing on the JVM. And when you can pull out parts of it that don't actually depend on Android or JVM APIs, you get this common subset. And then that can run on other platforms like your iOS code, which then can also include other parts that talk to iOS-specific APIs. And then the Kotlin multi-platform toolchain kind of brings all of that together so that you can get this nice interop in your single project. And there's obviously, like, this gets more complicated when you have more targets, but the Venn diagram is too much to show on a slide. So we'll start with just that. So that's Kotlin multi-platform. What does Kotlin multi-platform Hello World look like? One of the nice ways to kind of do your very, very first explorations is the KMM plugin in Android Studio, which gives you these new project templates that will just give you a Kotlin multi-platform project with Android and iOS targets. These templates have kind of evolved a bunch over time. I used to not really like them a couple years ago, but the current state of it is pretty nice. And I'll walk through a little bit of what it looks like. So the common code, it gives you a shared module and then some app-level modules. And the shared module has some common code that has just defines this platform interface, defines an expect function to get the platform. And so expect and actual are these two keywords that multi-platform adds to the language that let you define a declaration in your common code and then give it an implementation in the platform code. And we'll see those implementations in a moment. And then there's this greeting class that's a purely common class that gets an instance of that platform, asks its first name, and says hello. And what's nice about this structure is if you're using that greeting class and don't know anything about what's inside of it, it just looks like common. You don't know that it has this extra platform-specific behavior inside of it. That's just implementation detail. Another thing I like about this structure is platform is an interface where a lot of people, when they're first starting out with KMP, would define like expect class platform and then have an actual class in Android and an actual class in iOS. But when you use an interface instead, you have more opportunity to substitute other implementations. So if you wanted to have a dummy platform, a test platform, a dev platform that puts a different name out, you're able to do that just as a new implementation of that interface. And then the expect function get platform just gives you a kind of useful default, a little bit like having like a dependency injection where you have like a one definition per platform. So the Android main code just gives you a Android implementation of the interface, gives you an actual declaration of get platform to return that implementation, and talks to the android.os.build APIs to do that. iOS is similar on the other side, talking to UI device APIs. You might notice a subtle little difference here where the Android code that it gives you is just including the number of the version that you're in, whereas iOS is giving you the name, which is, depending on your use case, like sometimes you see something like that as an inconsistency that you want to fix. Sometimes it's a useful bit of flexibility, but just a funny little demo because that's what it generates for you. And then there's an Android app layer that, don't worry about all the extra noise. The important piece is it's going to create this greeting view composable and call your greeting.greet inside of it, and then render that to screen. And then iOS does similar, but in Swift. We're using Swift UI. And this template is a nice playground to kind of get started learning how KMP works. You just kind of like walk through 5 different places that your code can live, and they're all kind of useful places to start doing some experimenting and get a feel for what you want to live where in your own architecture. Yeah, you might start to find like the line between what lives in like the Android app layer or the Android main source of the shared layer can be a little bit blurry. On the iOS side, it's a little more strict because the iOS main is your Kotlin side and the iOS app is your Swift side. And it's often useful to kind of parallel what's in the iOS app and the Android app and vice versa. But you can move things around more on the Android side if you want to. The new elements it gives you give you some options around how you want to package your iOS dependencies, which is a bit of a complicated thing when you're not very used to iOS development, but there's kind of different options for how you export your Kotlin to iOS, where iOS has 2 major dependency managers that people use. There's CocoaPods is the older one that's commonly used, and then SPM is Apple's kind of first-party supported thing that a lot of people are moving to. And then there's also an option to kind of directly wire things into the Xcode project without using one of those dependency managers at all. And then while we're talking about Hello World things, I'll also mention CampKit is a sample app that TouchLab puts out. It's a little bit more than Hello World because it demonstrates kind of a lot of our preferred architecture patterns and dependencies and things like that. So instead of just being a Hello World, it's got a repository layer that has some network work and database work, and then a view model that gets wired into the Swift UI and Compose layer. So if you want something that's kind of like a little bit closer to something that looks like the real world, that's a good kind of step to look at that one. And there's plenty of other samples obviously out there, and a lot of them show some common themes when you're doing kind of like your first KMP sample. So it tends to be the case that most of the code base will be shared. So you'll have usually like separate UIs, but a lot of the architecture inside of it will be in shared code. And usually everything will be in a monorepo. usually they'll be built in such a way that the Xcode project is going to call into your Kotlin build, which means if you're an iOS developer, you need to also have the JVM tooling installed to be able to run that. So it's going to call Gradle and rebuild your Kotlin every time to pick up updates. But that means you need to have all that tooling in place. And usually it's going to be a single module because it's going to be just like a small little sample. And all of these are things that look a little bit different when you get to larger and larger real-world projects. So let's talk about the real world a little bit. And I will start by talking a little bit more about shared code. So obviously, one of the things that we all really like to do as software developers is avoid rewriting things or avoid writing things twice when we don't have to. And that's like one of the lovely things about shared code is being able to have two apps or have many things potentially if you're using other platforms, and be able to write that code once and run it in lots of places. Leads to less dev time, avoids duplicated work, avoids divergent implementations where the Android side and the iOS side are different in subtle ways, and you can fix your bugs once instead of twice. And there's a lot of times when going all the way with that is a really nice goal, but sometimes it's not what you want. And it's important to remember that like it's okay to have even significant amounts of platform-specific code in your Kotlin multi-platform project, depending on your team and your preferences. Everyone kind of has a different sweet spot of where they want their shared code boundary to be, how big they want their shared code to be. Maybe you want to do compose on iOS and share everything. Maybe you want to share your view models and do native UI. Maybe you just have one critical business logic class that you want to share, and everything else you're going to do separately natively. And where you are on that spectrum can also change over time. A lot of times, if you're adopting stuff in an existing app, you want to start small and then grow it out. And you shouldn't, like it's good to not take sharing everything as your goal right off the bat. Like it's okay to start small. It's okay if you're always a little small. It's still helpful to have that shared code. And I've even seen teams move in the other direction. So I was in a conversation a couple weeks ago with a client who was starting to do shared view models, and they found that that it was actually making things a little bit more difficult than they wanted for their iOS developers, and they'd rather just share their data layer and do separate view models. That's not everybody, but like everyone kind of finds their own spot there. One thing that can be really helpful, that's not in that new project template immediately, but is a good thing to kind of try out first in there, is adding a Swift implementation of a Kotlin interface is a really useful tool for bridging the Android iOS developer gap, where Swift can implement a Kotlin interface, which means if you have some complicated interface that you want to interact with from your shared code, your iOS developers can implement it using all of the same tooling and libraries and things that they're used to, and then your shared code can still talk to it. And this can be this can just be like a really useful piece of your architecture when you're trying to figure out where your shared code boundary is. Talking a little bit about the human side of things. So here's a realistic picture of a software engineer. I mean, there's two things in this picture. There's a computer where the tech is all happening, and there's a person, because the human side of things is just as important as the technical side. So every team has different patterns they like, skills, preferences, and there's a social problem as much as a technical problem of figuring out how you're all going to work together. I was having some conversations with a couple people I think I see in the audience actually about this over the last couple of days. And one of the big pieces of advice that I keep giving is don't just treat Kotlin Multiplatform as something you're kind of throwing over the wall to your iOS team. Treat it as something that you're going to do, like adopt together. It's a social problem, it's a technical problem to get that all running. And you can let them keep doing what they enjoy and what they do best by kind of leaving some of the stuff in the in the iOS specific code. You're never going to be able to sell KMP to your iOS developers by telling them they have nothing to do, because we're engineers and we like doing things. We like building things. So as you get out to bigger and bigger teams, the way your team is structured will have different impacts on the way you want your code to be structured. And it's worth kind of being thoughtful about how your team structure impacts that. Sometimes you have a small team, sometimes you have a large team. Sometimes one of the big kind of differentiators can be whether the people who are consuming the shared code are also writing it. So do you have people that are both on the Swift and the Kotlin native side, or do you have people on Kotlin who are passing code to your Swift developers? Like which side of that you're on will affect how you want to structure things. Are you trying to share a lot versus are you trying to share a little or change things? When you have a smaller team, you tend to have more shared architecture. You have fewer kind of worries about who owns what parts of the code. And it's a little easier to have kind of a lot of shared code and just a thin UI. When you have a larger team or your pre-existing apps that are like starting to pilot KMP in your already large code base, you tend to have a bit more constraints. So you'll have more iOS specialists who might not want to deal with building Kotlin. Your Kotlin stuff will be kind of just one thing among a bunch of other native SDKs. And it gets more important to minimize the impact that the Kotlin has on the rest of the code base, so that the rest of the code base can kind of keep going as it is. And here you're more likely to, rather than do the monorepo thing that the Hello World is demonstrating, you're more likely to want to have like a published version SDK that you can be pulled down sort of as a remote dependency, like other published dependencies are. One of the other kind of similar differentiators among different projects that often comes up is like when you're pre-existing apps, like you're often in different repositories, and so talking to the Kotlin directly from iOS gets more difficult. So what we often recommend those sorts of teams do is you publish your Kotlin native code to some sort of artifact repository. This is usually not something that small teams want, but it's very helpful for large teams and pre-existing apps. So the benefit is the iOS team no longer needs to deal with any of the JVM and Kotlin tooling unless they want to, and can build things without needing to, like you don't need to wait for the Kotlin native builds can be kind of slow, and you can avoid kind of pushing that cost towards your iOS side. The downside is you get some slower iteration because you have to publish a new version each time. But when you're a large enough team where this becomes a problem, like where you have people that want to just do the iOS side of things, usually you have some of that slower iteration already. So it's not as big of a issue. And one of the other products that TouchLab does that can help with some of this is called CAM Memberage. It's a Gradle plugin that essentially makes the Kotlin native iOS SDK publishing flow a little easier. And it lets you kind of jumpstart moving from that monorepo flow to something that's more separated. And essentially the way it works is it adds a Gradle task that you can call when you want to publish a new version. We also ship a GitHub Actions CI script that can help you get it running quickly. And it has lots of configurability around where you want your artifacts to live, and how you want to handle versioning. So you can like automatically bump versions every time you run the task and stuff like that. It also has some helpers and documentation guidance around flipping between using a remote publish dependency and building the code directly when you're making changes to it and want to see how that looks in the iOS app. Yeah, definitely recommend giving that a look when you're getting started and trying to get this kind of publishing flow to work. It has options to publish with CocoaPods or with SPM. And if you're not sure which one you want to use, it's a good first question to ask your iOS team when you're reaching out and trying to work together. Another piece that comes up as apps get bigger in scale is how you modularize. So like in Hello World, you're always in one module. When you're in the real world, you're generally building more. And this is one of the kind of pain points in Kotlin Native right now, where when you have multiple modules on iOS, they essentially can't talk to each other. So the way that Kotlin Native compilation works, each of these modules here is essentially its own separate ecosystem, and any dependencies that they share will look different at the binary level. And you won't be able to kind of take something that comes out of one and pass it to another, unless it's like a primitive type or something they both know about. So this has a little bit of size impact because like shared dependencies will get duplicated. Usually it's not too significant because the dead code elimination is pretty good. But it can limit kind of some of the things that you want to do with your architecture. So one of the workarounds that a lot of teams end up doing is you add this extra kind of umbrella layer just on the iOS side that packages it all together, does whatever wiring between your different modules you need. It can still be a little bit messy because all of your modules underneath this will now share a same namespace on the Swift side, and you can get naming collisions and things like that, which Kotlin will solve by adding underscores in ways that aren't very intuitive and can be a little confusing. But if you're careful about keeping your names distinct across different modules, you can work around that. And there will be improvements to all of that namespacing in the future. It's one of the kind of big tickets in progress on UTrack right now. One of the use cases, so it's often true when you have kind of a more complicated architecture that you want to be able to talk between the different modules, but there can be some nice cases where they're doing distinct enough things that you can still kind of leave it separate and be kind of more in this mode. So like if you have a shared analytics module that's mostly being triggered from UI and your UI is all platform specific, then sometimes that can be completely isolated. But when you have more complicated things, often the umbrella framework can help. A related concern that comes up as you're growing is dealing with the kind of binary impact of your Kotlin code. So like your hello world is small, but in the real world you want to avoid getting too large as your code base starts to grow. And there's a subtle thing that can happen here where the way that Kotlin Native talks to Swift is through Objective-C. And it turns out that the way that bridging layer is generated adds a lot to your binary. So if you just had Swift and Kotlin, you wouldn't have too big of an impact, but once the Objective-C bridging is in there, it gets more significant. And the lesson that comes out of that is you want to, where possible, kind of limit how many public declarations you have to just the ones that you need to call from Swift. So if you can make that box on the left a little bit smaller, then you're limiting the impact of the Objective-C bridging size. Something to watch out for with that is like Kotlin's default visibility is public, and so it's really easy to expose things that you're not thinking about. There's a explicit API mode that you enable in the compiler, which will force you to always write a visibility. And that can be a nice way to kind of be more conscious of what you're exposing to the iOS side. Another thing to watch out for is generated code. So like you might not realize that the code that you're generating somewhere is exporting public declarations. And a place where this often comes up is if you're using SQLite for your database, it will generate a lot of like database model and interaction classes, and most of its APIs are all public. So it can often be helpful to kind of put that down a module layer so that those generated classes aren't being exposed to your iOS code if the iOS code isn't using them. Something that can also help with this is, in general, is having a split between, kind of splitting your modules between implementations and interfaces, so you can export the interfaces to your Swift, but keep the implementations private to your Kotlin. Hello World app tends to have a small API surface, but in the real world, as things get bigger, like the shape of your API gets complicated, and how things fit together really matters. So Swift and Kotlin look superficially very similar, but under the hood, they often do things in slightly different ways. So for example, you use data classes in Kotlin when you're kind of passing data information around. Swift will usually use a struct, which is a value type rather than a reference type, and you have to kind of think about the difference between those semantics. When you're doing reactive things, Kotlin has coroutines and flow. iOS has its version of async await and async stream. And the shapers of the APIs, like, they have a lot of similar concepts, but they do things in slightly different ways. So like flow, you call a collect function. Async stream, you usually collect by just running a for loop. And with all of these sorts of things, you often end up you often end up kind of wanting a little bit of a translation layer, so that you can so you kind of move from, like, in your Kotlin code, you want to be writing animatic Kotlin. In your iOS code, you want to be writing animatic Swift. There's often going to be a little bit of bridging that happens somewhere to kind of do that conversion. And I generally say, like, don't be afraid to do a bit of extra work to make that bridging a little bit smoother. Like, you're saving some time by having shared code, and so you have a little bit of leeway to do some extra work to kind of make the shared code good. TouchLab also has some tooling to help with that. So we have this new product called Sky. That's called the Swift Kotlin interface extender, and it can provide kind of better interop around a bunch of different kind of API types. So it gives kind of better interop for enums and CO classes, suspend functions and flows, things like that. Right now, it's a paid product where we're kind of targeting it for larger organizations looking for enterprise level support. If that's you, then we'd love to talk to you. Feel free to come bug me and ask me questions. There's also a coworker of mine here who's, I think, somewhere in the audience. Yeah, Tadias over there. Talk to him too. He wrote most of it. But we're very invested in kind of building better tooling to make this interop layer better, and we'd love to help people with that and get feedback on how well it's working. So I'll kind of finish up with a couple different sort of case studies around API design, sort of things that have come up in some of the projects that I've worked on, where we had to kind of, do some work to kind of make our shared code work the way we wanted it to. I've kind of changed all the names of things to protect the innocent, but these are all kind of examples of things that have come up in real projects. So One was taking a view model that lived in an Android app and kind of converting it to have shared view on a layer that could also expose to iOS. It had this constraint that the screens at the time were all still using live data, and they didn't want to kind of heavily refactor all of the UI, and we wanted to kind of just target the view model layer to make changes. And so what we ended up doing is kind of pulling out this common view model layer that did all the same work but exposed things as a flow, and then just adding a thin wrapper at the Android layer that takes that common view model and just converts all of its flow APIs to live data. And like there's already Kotlin coroutines already kind of provides you useful helpers to do that. So it ends up being a little repetitive, but it's easy to write. And then on the iOS side, it was a little bit more work to wire up, and there's better ways to do this now than what we had at the time. But we were similarly kind of taking that common view model layer, kind of wiring callbacks into it, and then from the Swift side, we could implement those. We kind of pass things into those callbacks that would then wire out to iOS asynchronous APIs. It's often like this sort of pattern kind of comes up a lot when you're trying to carve out like where your shared code boundary is, and it's the kind of thing that can often be helped by things like compiler plugins. And so like one of the things that Sky does is kind of hit some of the common use cases for some of these patterns. Like it's often not too bad to at least start doing some of this stuff by hand and figure out like what are the patterns that you want, and then you can sometimes write your own generators for some of it. And there's other libraries also that exist to help with some of the common patterns now. One of the other kind of interesting lessons here is like, in this case, like the thing that was the seam between the shared code and the platform code was kind of in the middle of the view model layer. It wasn't really exactly aligned with what your traditional architectural boundaries are. And so kind of thinking about being flexible with that kind of thing can be helpful. And view models are always a funny edge case with a lot of this stuff because they are kind of the edge of your UI. And your UI is often a thing that you want platform specific, at least these days in KMP. And so kind of figuring out exactly where that boundary is for your project can be funny. Another kind of similar one, I think this was on the same project. We had a bunch of we were trying to kind of migrate some socket-based logic. So there was this sync service that was doing all this complicated communication. Android had a bunch of complicated logic using Java sockets. The socket connection was kind of like creating and destroying sockets and sending messages through them and things. And we didn't want to heavily refactor that and risk breaking any of these in the Android stuff. The Android app was already deployed widely. And there was all this kind of complicated business layer logic on top of it that was kind of doing the sync operations. And that had already, like that we had moved to mostly common code at that point. And so what we ended up doing is kind of creating this socket interface and a factory created that just wrapped directly around what were the socket operations that socket connection was doing. And then we could create iOS and Android implementations just of that little bit of code that needed to be platform specific. So Android was using essentially the same existing socket calls it had before. iOS was using the iOS native socket connections, which is NW connection from the network framework. And so we were able to kind of find this platform specific seam underneath that common logic. And this was a similar refactor to something that you might do if you're trying to take a legacy class and make it more testable. Like maybe instead of having different platform implementations, you wanted to write a test around socket connection and pass in a mock version of your socket so that you weren't kind of running it with real communications. And so the lesson in there is like a lot of the lessons that you might have learned as you're kind of refactoring legacy code can also be really helpful when you're migrating to shared Kotlin. And then the last, how am I doing on time? Yeah, the last example I'll show is, this was in a Greenfield app, essentially, where we wanted to, one of the features it had, it was essentially a white label app SDK where the clients of our client could kind of configure their app to use different integrations, and one of the options was what analytics service you were using. So there was kind of an internal thing that just talked to their server, and then there was like a Firebase and Facebook analytics integrations. And one of the questions that came up in there that they asked us as we were building this was, well, is there a KMP SDK for Firebase or for Facebook Analytics? And there's some stuff around Firebase, but what we ended up doing was just kind of building platform-specific code just to talk to those integrations. So I'll skip through so yeah, we had the internal one that was just kind of talking to the API. We had a combined one so you could have multiple things. And then yeah, on the Android side, we had a Firebase thing that talked to the Android Firebase APIs, and that just lived in the Android code. And then on the iOS side, we had a similar thing that just talked to the iOS Firebase. And there was a similar thing for the Facebook Analytics. And kind of one of the lessons there is like it's really easy when you're first starting out to, like, one of the traps you fall into is you really want to just find the library that already exists, and you look for what's the KMP library that already exists. And there's libraries for a lot of things. There's a lot more than there was 3 or 4 years ago, but not everything is there yet. But most of the problems you're trying to solve have been solved on the platforms that you're using. And so being able to kind of split out into platform code, talk to the dependencies that you're already used to talking to on those platforms, and then kind of inject that into your common code is just a useful skill to have. So yeah, I'm going to skip this last section because I think I'm about out of time. Yeah, so just to kind of sum everything up, the world is complicated. There's a lot more going on than you might first think when you're just doing kind of a simple Hello World project. Hopefully I've been able to kind of give some insight into some of the more complicated problems that can come up. One of the, and yeah, just to kind of repeat some of the lessons, like a lot of the things that come up around architecture, around kind of like building clean architecture and things like that, in your single platform apps are also really helpful in KMP. So things like separation of concerns, isolating your dependencies, different refactoring techniques with legacy code. So just keep all of those skills in mind as you're adopting your Kotlin multi-platform. Remember that the human element is as important as the technical element, and doing things in a way that keeps your iOS developers interested, engaged, and doing the things that they like to do as much as you're doing the things that you like to do is important. And 100% shared code doesn't need to be the goal, and that's totally okay. So with that, have a nice Kotlin for the Kotlin that you are writing. And thanks for coming to my talk.